Okay, we're going to start with ventricular volume measurement. And this is explained on pages 72 and 182 of your textbook, and it does a pretty good job of explaining this. So I do recommend reading those pages also. Um, so this is how ventricular volume measurement is done. You do a ventriculogram in the RAO position. So that's what we have here. And this picture on your left is the left ventricle during diastole, when the heart is at rest. And so when the heart is at rest is when those ventricles fill with blood. And then the picture on your right is the heart, or the left ventricle in systole. What they do is they literally trace a line around the ventricle. So here in diastole they trace around, and then in systole they trace around. Okay, now once the tracing has been made, the computer can calculate the volume. Okay, so this isn't like a manual calculation that we do. What we do is just simply trace around the ventricle. And then once the ventricle is traced, then the computer comes up with the volume. So, for example, the end diastolic volume for this one could be 75 milliliters of blood, and the end systolic volume could be 25 ml of blood in that left ventricle. So in order to figure out the stroke volume, which is the volume of blood ejected in one contraction or one stroke, you just simply subtract the ESV from the EDV. So the answer would be 50 ml. So there was 50 milliliters of blood ejected in that one contraction. Now we also have to figure out the ejection fraction. So this is the actual amount, but then they also want to know what percentage of blood is being ejected. So then for that, you take your stroke volume, which is 50, and divide it by your EDV, which was 75. And so you'll have to get a calculator, and with that it gives you 66%. So this person's stroke volume is 50 and their ejection fraction is 66%, which is in normal limits. Remember, there will never be an EF of like 100%, because not all of the blood is ejected during a contraction. Okay, now I've scrolled on down here to the cardiac output, the angiographic method. The cardiac output angiographic method goes hand in hand with the stroke volume and ejection fraction. So I'll go ahead and kind of put these together. Okay, so the first thing to remember is that cardiac output is the amount per minute, and it is displayed as liters per minute. So the cardiac output is how many liters per minute the left ventricle ejects. So the angiographic method is what we're going to look at now, and this is the formula for it. So you have to have the stroke volume and you have to have the heart rate. Those are the two variables that have to be given to you. So again, we're going to pretend like this patient's stroke volume was 50, and then the heart rate is 60. So it's going to be 50 times 60, which equals 3,000. Now what that is, though, is 3,000 milliliters per minute. And so you have to bring the decimal point back 3 places, and so your answer is 3 liters per minute. So again, this is where it's important to know what the normal limits are. Your normal limits of cardiac output is 4 to 8 is normal. So so when you get a number like this, you know that it must be in the wrong, measurement. And so this just takes practice, but your answer was 3,000 milliliters per minute, which is 3 liters per minute.